Here's an example of a Born-Haber cycle using sodium bromide, and we have elemental sodium reacting with elemental bromine to give sodium bromide. The unbonded gaseous ions are therefore the sodium ion as a gas, the bromide ion as a gas. And to get from the elements to the unbonded gaseous ions requires breaking bonds, forming gases, and forming positive and negative ions. Breaking down each of these stages, we first of all say that to go from sodium in the solid state to the gas state requires atomizing sodium, breaking all the bonds in the metallic structure. To then go from the sodium gas to the sodium positive ion requires ionization. That's stripping an electron from each of the atoms. In terms of bromine, we're going to atomize to break the covalent bonds to form bromine, and then we're going to add an electron to each of the atoms to form the bromide ion. So a question may say, calculate the enthalpy change of the reaction sodium with bromine to go to sodium bromide, and the information which is given is first of all the atomization energy of sodium, the atomization energy of bromine, first ionization energy of sodium, the first electron affinity of bromine, that's the energy change when you add an electron to bromine atoms, and the lattice energy of the sodium bromide. Putting this information onto the chart, we can now see that to atomize the sodium requires 107 kilojoules per mole to get to the sodium gas. To ionize sodium, to remove the electrons, 496 kilojoules per mole. To atomize the bromine, to break all the bromine-bromine bonds, 97 kilojoules per mole, and then to add an electron to each of the bromine atoms actually releases energy, and that's minus 325 kilojoules per mole. So to work out delta H, the unknown enthalpy change here, we can go up these arrows, down that arrow, so 107 plus 496 plus 97 minus 325, and minus the 742 gives minus 367 kilojoules per mole. That's negative as you'd expect for an exothermic reaction, which you would expect for a metal reacting with a non-metal to form an ionic substance.